Welcome to Prince Math Clinic, the e-learning solution at your pace and time.
Good day, viewers, and welcome once again to class. Here we have a very interesting challenge before us. Looking at this question, we are asked to solve for the value of x and to check for extraneous root. By extraneous, we mean solutions that are not relevant to the equation. So at the end of our solution, we shall be substituting the values we have obtained for x to see if they will fit in to the equation. So let's go right into the solution. We are given that x to the power of x to the power of 2 is equal to x to the power of 1 over x. Notice one thing, the bases are the same. You can use the principle of since the bases are the same, therefore the powers are equal. But if you do that, you'll be very wrong. The reason is because you will not be wrong in the sense that your answer will be wrong. You're only going to get part of the solution. Doing this would have reduced the chances of getting all the solutions there is to this particular question. So the approach I'll be using is to move what we have to the right to the left. So I will have x to the power of x to the power of 2 minus, if you move here, x to the power of 1 over x. Then I want to factor out, then always say equal to what? 0. I want to factor out x to the power of 1 over x. So this will give me x to the power of 1 over x, open bracket. Then this, since we are going to be using what? The law of division in indices that says what? When you are dividing, because you are going to say x to the power of x to the power of 2 divided by x to the power of 1 over x. So it's going to be like this: x to the power of 2 minus, then subtract this from it, which is 1 over x. Now, to know you are correct, you multiply this together, know you are adding up the power. So 1 over x minus 1 over x leaves you back with x to the power of 2. So you know you are right. Minus, then this divided by this is just 1, equal to 0. Then using the product law that says that if I have a times b equals to 0, I can say a equals to 0 or b equal to 0. I can say that in my first case, my x to the power of 1 over x is equal to 0. So this is the first case we are going to be treating. And to treat this is very simple. I have x to the power of 1 over x equal to 0. So what do? I want to multiply both powers by what? X, to eliminate this x. So x to the power of 1 over x times x is equals to 0 to the power of x. So x here, we cancel x here. Therefore, our x, since x to the power of 1 here means x, 0 to the power of any number is still 0. So our x here is 0. So that is the first solution to x. So I'm going to call it x1. So let me document that here, that my x1 is 0. Now let's consider the second case, and that is this. Everything I have in the bracket equal to 0. Now, this is what I have in the bracket. To solve this, I will have to move my negative 1 to this part. It becomes positive. So I will have x to the power of x to the power of 2 minus 1 over x equal to 1. So in order to solve this, I also mentioned the mistake that most students are likely going to make. they might likely going to make this mistake to say, since this is 1, then they will say that x to the power of x squared minus 1 over x is equals to x to the power of 0, because anything to the power of 0 will give you 1. So that they can now say x squared minus 1 over x equal to 0. If you do this, you have also reduced the chances of getting all the values you can obtain for x in this equation. So the way to go is to take the natural log of both sides. So doing that, I will have ln x carrying this as the power equals to ln 1. And using the laws of logarithm, when a log is carrying a power, the power multiplies the log. Then this becomes x squared minus 1 over x ln x is equals to ln 1. And ln 1 is 0. Therefore, I'm going to say that what? X squared minus 1 over x ln x is equal to what? 0. From here, I can put what I have here. Since I multiply this with this, I can put what I have here in a bracket. So let me do that. Put this in a bracket. Good. So it's clear now that x squared minus 1 over x is multiplying ln x. So using the product rule once again, that says when two values are multiplied, each of them is equal to 0. So this gives us second case. My ln x is equals to 0. So what does that mean? If my ln x is equal to 0, I want to eliminate this ln. The only way to do that is to say e to the power of ln x equals to e to the power of 0. And your ln will cancel your e. And we know that anything to the power of 0 gives us 1. So here is another solution to x. So we'll call this x2. Then let's move on to the third case to now make x squared minus 1 over x equal to 0. Now we have that x squared minus 1 over x equals to 0. Then I want to multiply everything here by x. So this becomes x squared minus 1 over x multiplied by x. Now what you do to the left, you must do to the right. So this becomes x times 0. So if I multiply this with this, I'll get x cubed. If I multiply this with this, I'll get 1. And if I multiply x with 0, I'll get 0. And remember, I can decide to write 1 as 1 cube. They are all the same. 1 times 1 times 1 will still give me 1. Then remember the rule that says that if I have a cube minus b cube is equal to what? A minus b in the bracket, then a squared plus ab plus b squared. Now, using this identity to solve this, what are we going to have? I'm going to have that what? X, my x cubed minus 1 cube will now become, now assuming that my a is x and my b is 1, I'm going to have x minus 1. Then I'm going to have x squared here. Then AB means x times 1. Then b squared means 1 squared. Remember, all of this is equal to 0. Therefore, I have x minus 1 and x squared plus x plus 1 equal to 0. So therefore, using the product rule again, right? I have my fourth case. I have my fourth case to be x minus 1 equal to 0, right? Therefore, my x will be 1. Also, I have that this, as my fifth case, is x squared plus x plus 1 equals to 0. Now, this is a quadratic equation. And treating the quadratic equation, right, we need to first of all find out what the discriminant is. So, to see if it's going to give us real solution. And my discriminant is simply b squared minus 4ac. Where my invisible one here is my a, my invisible one here is my b, then my c is also 1. So b squared means 1 squared minus 4. A is 1 and my c is 1. So this becomes 1 squared is 1, 4 times 1 times 1 is 4. And 1 minus 4 is negative 3. Hence, my solution to this, because of the discriminant, cannot be real. But in any case, let's try to solve it and let's see what it's going to give us. Remember, that is the fourth case. And my fourth case is that x, right, squared plus x plus 1 equals to 0. So let's use the formula proper now. I have minus b plus or minus square root of b squared minus 4ac over 2a. Minus b is this negative 1 plus or minus. We have found b squared minus 4ac to be negative 3. Then over 2a, 2 times 1 is 2. Right? Remember, this is both the value for my x3 and my x4. So, but simplifying this, minus root 3, what does it mean? It means that my x3 and 4 will be minus 1 plus or minus square root of negative 1 times square root of 3 all over 2. And we know that square root of negative 1 is an imaginary number. So, doing that, I'm going to have my x3 to become minus 1 plus root 3 I over 2, and my x4 to be negative 1, negative root 3 I over 2. So these are my values for x. x1 is 0, x2 is 1, x3 is this, x4 is this. So let us check to see if we have extraneous solution. Putting the value for x1 into this equation means 0 to the power of 0 to the power of 2 equal to 0 to the power of 1 over 0. Let us put this in a bracket. 0 to the power of 2 means 0 times 0, which is 0. Then, remember, carrying a base of 0. Then, 1 over 0 is what? Is undefined. Because you are saying that you are going to divide 1 with nothing. It's undefined or infinity. So this becomes 0. 0 raised to power undefined. And 0 to the power of 0, what does it mean? Nothing to the power of nothing. It's not the same as 0 to the power of undefined. So 0 is not a solution to this. I would like you to put your comment in the comment section. Let's debate this together as mathematicians and professors in mathematics. This is open to debate. Drop your comment section. I want to learn from you. Thank you. Then let us check the value for x2 to see if it's extraneous. I have here that 1 to the power of 1 to the power of 2. Will it be the same as 1 to the power of 1 over 1? 1 square means 1. Then 1 to the power of 1. Then here you have 1 over 1 is still 1. So they are equal. So it means this solution is valid. And of course, substituting the values for x3 and x4 are not real. Why? Because of the imaginary numbers that we have there. So if this video was helpful, kindly give it a thumbs up, share this video to your friends and loved ones, and subscribe to this channel if you have not done so. For one reason, we share challenges like this on this channel, and we also encourage you to become better in mathematics. Thanks, and bye for now.